Hello, everyone, and welcome back to Identity Insights by Indicio. Today, I'm joined by Sam Curren, the Deputy CTO of Indicio, as well as a member of the DIF Steering Committee, to talk about the recent W3C DID-Core spec decision. Thanks again for making time for me today, Sam. Is there anything else you'd like to tell us about yourself before we begin?
Uh, Not in particular. I'm glad to talk about this topic. It's kind of monumental, and it's good to get into it.
All right, awesome. So let's start by defining a couple key terms before we really get into the decision. Could you please tell me what the W3C is?
I can. It's an organization. The long form of the name is the World Wide Web Consortium, and it's an organization dedicated to standardizing mostly browser-based technologies that help make the internet a standard place. The fact that we have multiple browsers that all work with most websites, pretty well most of the time, is credit goes to the W3C for that. So they have working groups and community groups that are part of the W3C, and the DID core spec was part of one of those groups.
Okay. And before we talk about DID-Core, let's talk about internet identity in general. Can you talk about the current state of identity and how we got here?
Yeah, the internet was not created with an identity layer at the beginning, and so we've been kind of compensating for that ever since. And here's what this means in non-technical terms. When you go to a website or you use an app or something, you're often asked to log in, usually with a username and a password. And that's a mechanism for identity on the internet. They want to know who you are so that, for example, when you log into the bank's website, they know which accounts to show you and which accounts they should not show you because they belong to someone else. And so that's the basics of identity on the internet. It's a little bit deeper than that in the sense that if I want to send an email or communicate and have you know it's me, then that's also part of the internet identity problem. And that's something that we don't actually solve very well currently, which is why spam and phishing and other sorts of problems on the internet exist, is because we don't actually have good identity solutions for those. So each of the whenever you have a username or you have a Twitter handle, a username on Twitter or on another social media platform, that username is often your identifier. That's how people find you, and so that identifier is is important because that's what you tell people. Oh well, you can look up, for example, on Twitter. I'm Telegram Sam on Twitter is my username. The problem with that identifier is that it can be taken away by Twitter. They can decide that I should not have that anymore and remove it and or give it to somebody else. And that's a problem when you're trying to form really strong foundations of things with identity at the core. And so all of the identifiers currently on the internet, email addresses, domain names, social media handles, those can all be taken away from you without often much you could do about it. And so that's a problem that we have, and that's the state that we are now. And why the DID core spec is actually so important is specifically about the fact that identifiers can be taken away from you.
All right. So what is the DID-Core spec now then?
So the DID core spec describes a method for decentralized identifiers. So DID is actually a little short for decentralized identifiers, and most DID methods, I'll get into a little more technical detail in a second, but most DID methods are built in a way that your identifier and the associated information are recorded in a way that cannot be taken away from you. And that's pretty important because that way we can build things as a foundation without worrying about people having things sort of revoked from them, and that's necessary to be a foundational piece of the internet and change things the way they're trying to. So the spec itself describes the general mechanism by which this happens. It allows for DID methods, which are very specific ways of sort of implementing the DID core spec that describes sort of the general mechanism, and each DID method is a specific mechanism that enables that to happen. And so different DID methods have different attributes and different qualities to them. Some, for example, are connected to Ethereum or to Bitcoin. Some are connected, but in slightly different ways. For example, there's a side tree protocol that Microsoft Ion uses as one of the DID methods. It does things a little bit differently than directly anchoring to a ledger, but still has lots of those benefits. And so there's different DID methods, and each of them provides slightly different mechanisms for that. DID Indy, for example, is a DID method that is used to connect identifiers or to register identifiers on Indy-based networks, Hyperledger Indy-based networks. So there's two parts that are involved here with the DID core spec. There's the decentralized identifier, or the DID itself, and then there's something called the DID document. And the identifier can be used with the DID method to resolve the document. And that document contains, it's not a human readable thing. It's like it's a technical document, but it contains two really important things. It contains private keys. And so this is a security setup where you have a key pair. There's a public key and a private key, and you can use that to do cryptography and signing. And so the public keys are associated with your DID document. And then, of course, you keep your private keys, and the DID document also contains service endpoints. And service endpoints can be used to sort of begin interactions or communicate with the owner of the DID. And so those two pieces are described in the mechanism in the DID core spec, and then implemented by DID methods that are associated with it. For those familiar with public key infrastructure, PKI, this is a little bit of a different approach on PKI. The fundamentals are still the same, but how to publish and discover those the public keys associated with an identifier are a little different there.
All right. So why was the decision to accept it up for debate? Could you go into what the arguments for and against accepting DID core were?
Yeah, that's a good question. And this is going to be a brief summary, and I'm unlikely to be thorough in my answer. Those can be found if you look online, but if you're looking for a summary, I'll attempt to do that here. The first thing is that this work has been going on for a while, and what has happened now is a status change. The working group, the community group that has been working on the DID core spec is seeking for a status change from something that's in progress to a W3C recommended spec. And that carries a lot of weight. There's a little bit of expectation of support in internet software for a W3C recommended spec. So that status is an important one for the spec to achieve. So it's got to be pretty polished and really put together. And there was a ton of work by so many that went into that and to get it to that point. There were a handful of objections, and it's hard to directly summarize them all, but I'll try to. I think that a lot of the specifically mentioned concerns were the number of DID methods associated with the DID core spec, and in two ways. One is that there's a lot of them, and the other one is that the spec itself does not designate sort of mandatory DID methods that are part of its operation. And there's a couple of reasons why that wasn't done, and part of it is that in order to recommend something like that, though, everyone involved has to reach a consensus on what those required ones should be, and that's a difficult thing with a new technology. The other aspect of that is that there's so many DID methods. There's quite a lot of them, and it's worth noting that you can declare a DID method simply by writing some documentation about how it should work and then publishing that. That doesn't necessarily mean that all of those DIDs for all those DID methods will be an active practice in all of the ecosystems. And I expect that in most ecosystems there will be a set of ones that are used for various purposes, and then you will simply need a DID of one of those methods in order to participate in that slice of the ecosystem. And that feels like that's not really a way to get together, but it's better than it sounds. Mostly because we, as the people working on this, will gradually, I believe, reach consensus on what the best ones are, and then the focus will be on using those ones in particular. So there was some objections about how many DID methods they were, and the lack of ones that said these are the mandatory ones, which left the spec a little bit squishy from the eyes of those that were looking at implementing this. Several of the people or the parties raising objections were browser manufacturers, and I think mostly their objections are a circumstance of the timeline, and I'll try and explain what I mean there. Back in the original days of the internet, it was really messy, and stuff was just getting invented really, really fast, and there was a lot less sort of standard support for most of the technologies that we have. We've reached a time now where the web has matured to the point where there is a substantial amount of sort of common standard things that work in all browsers, and it just mostly works. in the beginning of the internet, it mostly kind of worked. Right? There was a lot more. There was a lot more wiggle. Things kind of worked a little bit differently, and just because it was a newer technology. And I think that most of the browser manufacturers were looking at what they were being asked to implement, and they were kind of holding it up to today's standards of completeness or finality, and well-defined edges. But this technology is a little bit more like the early days of HTML, where it was a lot fuzzier and there was a lot less certainty about exactly where the edges were. And so I think that their perspective is mostly a circumstance of the timeline. And I hope that adds a little bit of clarity. I think, and if you read the decision about whether to accept this or not by Tim Berners-Lee, he addresses that a little, and then kind of voices like, given all of the good that this offers and some of the downsides that people have mentioned, we believe it's that the weight is on the side of the good, meaning having this as an accepted spec will do more good than not having it as part of the accepted spec, or the status change that they were pursuing. And so I think that I like that decision. He recognizes the fuzziness of what's going on, and then moves forward with it. So that's why there were objections and why this is a thing. I think that for most of the people involved in creating or promoting it, and I'm in that camp, I believe that this is a foundational piece of what we actually need on the internet, and so it's pretty important. I think that there are skeptics that don't believe that this really applies the same way or doesn't really carry the same amount of weight, and so it will. They're less excited about it because maybe it's a distraction, or maybe they think, well, this is just like cryptocurrency or just like something else, and they're not sure how long it's going to be or how much volatility there's going to be in being involved in it. So for like established browser manufacturers, for example, browser vendors, it's a little hard to look at this and think, oh, I'm going to rush right into this because of sort of the weight and the complexity that it does actually have with it. So that was a little bit of a long answer, but I hope that adds some clarity on why this was a controversial thing, and then hopefully what will happen in the future as it develops.
No, it does. I absolutely appreciate it. So now that the decision has been made, what does that mean for developers?
What it means is that we can continue, and I say continue, to develop on top of this with a lot less fear that it's going to substantially change underneath us. I say continue because this has already been happening. Development on top of this has already been happening, and I think that the approval of this is likely to accelerate it. How much is yet to be seen, but I think it will likely speed it up. It's a little easier, for example, for some companies to fund development on top of a technology that has a stamp of approval than one that's still sort of pending and will probably stay the same. And so I expect acceleration or adoption of this to increase, but it's I want to highlight that this has been going on for a while now and not just something that can suddenly begin.
All right. And what does it mean for like the average person using the internet?
Not a lot yet. I think normal people are likely to see the side effects of DIDs rather than interact with DIDs themselves. And here's a little why. On the internet, we have IP addresses, which is how you send messages back and forth on the internet, but to other servers and such. But you have, and then we have domain names, and we type in, apple.com or google.com to go to the website. That's translated underneath the covers into an IP address, and the IP address is used. So DIDs are a little bit like IP addresses in that way, in that normal people are not really likely to see a DID, a decentralized identifier, directly. Their software will use those DIDs, but it's not something that we expect people to interact with directly or really see or need to understand in any way. It's a technical piece underneath it. The same way that I wouldn't expect a normal user on the internet to really understand what an IP address is. They're going to type in something, right? And they're going to get to a website and they're going to interact with it, and that's okay. That's the only level of understanding they need. But the side effects of this being adopted into technologies are actually quite cool. I anticipate an increase in data portability. I think it will spread faster and more consistent adoption of things like verifiable credentials. There's a great potential for things like portable contact lists, better integration between siloed systems that can happen as a result of having identifiers that are decentralized instead of identifiers that are rooted within some particular system or silo. So there's going to be positive side effects for normal people, but they're unlikely to look at something and say, "Wow, that's because the W3C changed the status on the DID core spec." That's not going to be a change that we expect normal users of the internet to experience.
All right, that's totally fair.
Right.
So if you could, would you be able to give us any kind of like roadmap, some kind of short-term and long-term changes that we would expect to notice?
Yeah, there's a bunch of related technologies to DIDs that have been being worked on for quite some time, but that it makes it easier to deploy those or approve those as they're rolling out. And Indicio, for example, has already been doing this. I mean, I work for Indicio here. We are representing this. We are supporting the Hyperledger Aries project, for example, which is deeply based on DIDs and DIDCOM and agents that interact with verifiable credentials and other things like that. So we've already been building on top of this technology, and I think that will accelerate. Also, the other dependent technologies, I mentioned DIDCOM. Getting into that is a whole nother conversation, so we'll leave that for another time. But work like that can accelerate because of the accepted status of the DID core spec. In some ways, it's a little bit of a formality because we've already been building on top of it, but it's a really, really useful formality because we don't really have to debate the merits of the spec anymore or how final the spec is. It has a stamp on it, it's been approved, and now we can develop on it with a little more confidence than we have in the past. I think that the long-term changes are likely to be very profound as a result of this. I see the DID core spec as a foundational piece of what we need the internet to be and some fundamental changes that need to happen. So I think when we look back, in internet years, this is a long time, but if you look back like 5 years or 10 years, thinking about the time scale of the internet, I think that we're gonna notice how much has been built on this core technology that didn't exist before. And then in hindsight, it will be obvious about how foundational it is. Right now, it just looks like one other thing that you can possibly build on. So I think the long-term changes are quite dramatic. The short-term changes mostly take effect in the lives of the people trying to develop the dependent technologies. And so I think that there's a lot of improvement there, but the sort of the trickle-down effects of getting to normal users will take a little bit longer. I have big plans for both for DIDs, teasing again DIDCOM, and why that exists. But I think that this has the capability of fundamentally changing the structure of the internet and in changing sort of the balance of the power and the nature of interaction in a really positive way for the betterment of a lot of things. I think we need better digital relationships. I think we need more security. I think we need security that you don't have to be very technical to do correctly. I think we need better key management. I think we need all sorts of better things like this. And this is a foundational piece, and I'm very excited that it was passed.
Sounds good. Well, with that is our time. So thank you so much for joining me today, Sam. If you want to read the original decision document, you can visit the link in the description. And if you'd be interested in learning more about decentralized identity, please be sure to subscribe to the channel as we'll continue to bring you some educational content. If you have any questions or specific topics you'd like us to cover, please leave a comment below and we'll be sure to address them. Thanks again, Sam.
Thanks, Tim.